We are starting Unit 7 today with Lesson 1, Properties of Quadratics. So this is a brand new type of function that we're going to be learning about. A quadratic function or a quadratic equation has an exponent of 2. So you're going to find this exponent of 2 on the x. And the graph is a parabola. So these U-shapes you see on the graphs, those are what we call parabolas. That's the name of the shape there. And what we're going to do today is we're just looking at key properties. So some of these you probably already know, but we will kind of jump back and forth from the top of the page to the bottom to do some defining of these. So the first key property we see is the y-intercept. So that is something that we know. We've done it with linear functions. We've done it with exponential. So I'm going to go down here to the vocabulary. So your y-intercept is where it touches or crosses the y-axis. Where it crosses y-axis. All right, and you're going to see that written as a coordinate. Remember, the x value is 0, the y value is your number. So that's where it crosses the y-axis. So if we look at these two graphs above, let's look at what our y-intercepts are. So on the one on the left, we look at our y-intercept to be right here. This is where it's crossing that y-axis, and that's at the y value -4. So we will write that as a coordinate 0, -4. And then we're going to go ahead and just do the y-intercept of the next graph. So we're looking, where does this parabola, where does this U-shape cross the y-axis? And that would be right here, where this red dot is. So that y value is -2. So we'll write it as our coordinate 0, -2. All right, next we have what is called the vertex. So we're going to go down here and define our vertex. So the vertex, it is the highest or lowest point on a graph. So the highest or lowest point on a graph. Sometimes you can refer to it as the turning point. Okay, so we'll look at these two graphs above, and you're going to see what I mean by the highest or lowest point. So if we look at this first graph, all right, notice that I can't say there is a highest point because technically these two lines are going to keep on increasing, going up on those the y-axis forever and ever and ever. So that means there is a lowest point. And when I say it's the turning point, notice that we are decreasing and then it turns back to increasing. So actually right here at our y-intercept in this case is also the vertex. So we would write that as a coordinate with an x and a y. So your x value there is 0, your y value is -4. So that is the vertex of this graph here. It is the lowest point. Then we look at the next graph. The vertex here, it's not going to be the lowest point because notice it is going to decrease. It's going to keep going down forever. So there's never going to be a lowest point, but it does have a highest point. And we see that with that turning point since it's increasing and then it turns to decreasing here. So that vertex is the highest point. And if we write out the coordinate, the x value there is a 2, the y value is a 0. So 2, 0 is the vertex. Next, we have our zeros and solutions. So if we go down to the vocabulary here, solutions and zeros, these are just other words for your x-intercept. So that is some vocabulary, some language you need to be familiar with. When you are asked for the solution to an equation or a graph, if you're asked for the zero of a graph, that is the same thing as asking for the x-intercept. So we should know what an x-intercept is. So let's just define that real quick. the x-intercept is where it crosses the x-axis. And this time your coordinate is going to be some number, comma, 0. All right, so let's look at the graphs we have here. So when it's asking for the zeros or solutions, notice that it is plural because with quadratic functions, it is possible you're going to have no zeros, there's possible to have 1 0, and it's possible to have 2 zeros. So if we look at our first graph here, notice that our parabola, this function here, crosses the x-axis twice, 2 different places. All right, and so we have to write out both of those places. So the zeros or solutions are going to be -2, 0 and 2, 0. So be aware that you may have more than one x-intercept. All right, so let's look at the next one. Look for a 0 or a solution, an x-intercept on this next graph. And notice that there's actually only one, and it's at the vertex here. So I only have to put 1 down, and that is also at the x value 2. So we would write it as 2, 0. All right, next we have the axis of symmetry. Now before we get into the definition of what this axis of symmetry is, you probably have heard what the word symmetrical before. And so what that means is, for example, a circle is symmetrical. So if I draw a circle, that means I can draw a line right down the middle, and if I were to fold it in half there, it would be equal on both sides. So in the same way, our parabolas are quadratic functions. They are also symmetrical. So we want to find where that line is that makes it symmetrical. So our definition here for the axis of symmetry is going to be the vertical line that divides the graph into 2 equal parts. So I'm going to have to go down to the next line here. Into 2 equal parts. And this will also always be an equation because it's a vertical line. So that means it's going to be an x equals equation always. So x equals some number. So the axis of symmetry is the vertical line that divides the graph into 2 equal parts, and it's going to be some y equals a number equation. So let's look at our graphs here. All right, so we are looking for where is this axis of symmetry. And one thing that will help us is our axis of symmetry will always go through the vertex. So on this first graph, we have our vertex in green. And so to draw our axis of symmetry, we just want a vertical line that will go through that green point here. So this right here is my axis of symmetry, and I hope you are also drawing this too. All right, so there's my axis of symmetry. Notice it is equal on both sides of that blue line. And the equation for it is going to be x equals, and then the x value here is actually at 0. So x equals 0 is my axis of symmetry. All right, so then let's look at the next one. Okay, so the axis of symmetry here, again, it goes through the vertex. So I'm going to draw a line that goes through the vertex, a vertical line. So this time, and again, it's going to stay the same as an x equals equation, but this time my vertical line goes through the value 2, which I know it's been covered up here, but this is a 2. So x equals 2 is my axis of symmetry. All right, the next thing, maximum or minimum. So what we need to know about a maximum or minimum is a graph has a maximum point when there is a highest point, okay? So for the maximum, we're just going to write that this is where we have the highest point, okay? The highest point. And then that minimum would be the opposite. It is when we have the lowest point on the graph. So when we look at our graphs, we're going to see, is it a maximum or a minimum? And we look to see, is our vertex at the highest point or is it at the lowest point? So let's look at these graphs. All right, so my first graph, since my vertex, remember we said it was at the lowest point here, that means this has a minimum. It has a minimum value, and that minimum value is at the y value there, which is at -4. So if you're ever asked what's the minimum value, it would be -4. All right, and then the next thing it says, does it open up or down? And this may help you when it comes to trying to decide, is it a minimum or maximum? What I like to say, is it up like a cup or down like a frown? So if I could pour water into this parabola here, into this U shape, and it holds it, that means it is up like a cup. Okay? So if we look at the next one, my vertex was here at the maximum, or at the highest point, I'm sorry. And so that means it does have a maximum point. That's when you have like a mountain. You can reach the maximum point of a mountain. So this would be a maximum point. And if you're ever asked what's the value at that maximum point, it's asking for the y value, which would be 0. All right, and so like I said, if we're looking at if it opens up or down, is it up like a cup or down like a frown? This looks like a frown. Here's some eyes. Aw, sad. Okay, so that means it's opening down like a frown. Okay? And then lastly, we have our domain. Okay, domain and range. So please remember, domain means your x values, range means your y. So when we talk about domain, notice there's no restrictions on these graphs. Nothing is stopping it from going left to right. Okay, so when you have no restrictions on this, it's going to hit every x value, which means your domain is all real numbers, or we can write it with this capital R. Okay. Now, the range, we have to be more careful. Just like with exponential functions, we'd look at the asymptote where that boundary was. Notice that where we have our range, all the y values, we have to look at the lowest or highest point first. So since this graph here has our lowest point at -4, that y value -4, that means I have this boundary at -4. My graph is not going to go below that. All of the y values are above -4. So that means my range would be that your y values are greater than -4. And there's one more thing we have to add. Because the vertex is on -4, it's included, it's going to be greater than or equal to -4. So we'll get to practice that one more time over on the second graph. So the domain, again, there's no restrictions, so it's all real numbers. For the range, and I'm sorry, I'm just now realizing this is wrangle. Ignore that L. Haha, that's funny. Okay, so pretend that just says range. So the range of this graph, we're going to look at this time the highest point, since there's a maximum. And there's this boundary at the maximum where this y value is 0. So that means, and notice that my parabola, it's not above 0, it's actually below 0 this time. So when I look at what my range is going to be, it's all the y values that are less than or equal to 0. It's equal to because your vertex is actually on y equals 0. So those are all your key properties today. All right, and I think we forgot one more vocab word down here, parabola, which is just the shape of the quadratic function. All right, the shape of the quadratic function. All right, so that is just kind of overview of all the different properties of quadratics. A lot of them should be familiar, but then there's some newer ones that you're going to get to practice today. You should have a second sheet of paper, so we're going to look at this next sheet of paper that goes more into the domain and range of the different graphs, and we'll look at when there's different restrictions on those graphs. So let's look at that next page. All right, so let's look at domain and range for parabolas with endpoints. One thing we do need to remember before we start this is what to do when you have an open circle versus a closed circle, okay? So when you have an open circle, that means you're either using less than or greater than. And when you have a closed circle, that means you're using less than or equal to, greater than or equal to. Now when we look at these segments of a quadratic with different endpoints, this should be familiar because we have done it with linear functions and exponential. We're just doing it again with quadratics. So we're looking at when there are two endpoints on a quadratic, okay? So when we talk about domain, that means it is your x values, right? So when I look at this part of a function, okay, I'm looking at how far left does it go on the x-axis. And so the farthest left it's going is actually right here at -1. Okay, so this is the boundary line from all the way to the left. And then I look at how far right does it go. And so this boundary line goes to where x is 2. Okay, so this is just like if you had a line segment from -1 to 2, and that's how we're going to write out our domain. So it starts, and then we go least to greatest, it starts at -1, and because there's a closed circle, it's going to be less than or equal to its domain, so that means we have an x, and then all the x values in here have to be less than or equal to, since I have a closed circle, this value of 2. So hopefully you can see that it is starting at -1, and it goes to +2. So that's where I have -1 to +2. And since there are closed circles, that means I have less than or equal to signs. So that's the domain. So then let's look at the range. Now we have to be careful with this. A lot of times I see students wanting to start, bottom to top, but with just the endpoints. If I start with just this endpoint here, notice that there is part of this function is still going below where y is 2. So actually, we have to start at the vertex, okay? Where y is 1, that is the lowest part of our graph, the lowest y value. And then the highest will be back up here where y is 5. So this is where we can kind of draw the box around it, okay? So the same process here when we do the range. The lowest point, so the smallest, is 1. And because it's a vertex, it's included. It's like a closed circle. We're going to keep it as less than or equal to. And it's range, so it's your y values. And then at the top, we have another closed circle. So all the y values have to be less than or equal to that value of 5. So we started where y is 1, and that's where I got this number. We ended where y is 5, that's where I have this number. Because I have closed circles or a vertex, that's why I have the less than or equal to signs for both. Okay, so let's look at our next one. So for our domain, again, we go left to right. So the farthest left on this function is going to be where x is -2. So that's where it starts. And the farthest right is when x is 3. Okay, notice we do have an open circle there. So when I write out my domain, I want to start it at the smallest number, so -2. Because it is a closed circle that is less than or equal to x, and then all your x values after -2 have to be less than 3. Since I have an open circle here, it is less than. All right, so then let's look at the range. So I look at the bottom to top, okay? So in this case, the bottom is down here at one of these endpoints where y is -7. And the highest it goes, it is not here at the next endpoint. It's actually at the vertex, okay? Right there. So when I look at the range, the lowest y value, the smallest y value is -7. Because there is an open circle here, it's less than y values. And then all the y values are going to be less than or equal to 2. Since that's where your vertex is, it is like a closed circle. Okay? So that's what we do when there are 2 endpoints on a parabola. So now we're going to look at what if there is one endpoint and one arrow, meaning we have one part of the graph stops, but the other side keeps going. So I'm going to move on to the second half of this paper. Okay, so with this one, it's the same kind of process of when we had rays. So if you remember a ray from linear functions, that's when you had a starting point and then a line that was shooting off of it, like a ray of sunshine. So when you notice that there is one endpoint and then an arrow on the other side, that means you need to look at where it starts at that endpoint. So when we do our domain, it is starting at when x is -2. And then you need to ask yourself, is this going to the left or to the right of -2? Is my arrow pointing to the left or the right? And obviously here it is going to the right. So all of my x values are going to the right of -2, which means it's getting bigger. So when we write out our domain, your x values have to be bigger than -2. And because we have a closed circle, it's going to be greater than or equal to -2. All right, so then our domain, now again, I'm just going to keep stressing that it's important that you're looking at this. For the domain, or for the range, for the range, we cannot just look at the endpoint, because if I were to look at this endpoint, there is still y values below 1 on our parabola here. Okay, so we have to look at the vertex. So the vertex here starts at 0, and that's like a closed circle. And you have to ask yourself, is this going above where y is 0, or is it going below? So this is actually going above. It's pointing up. It's opening up. So that means my y values, they're getting bigger than 0. They're greater than 0. So my range is y is greater than or equal to, because a vertex is like a closed circle, greater than or equal to 0. All right, so then let's look at the next one, okay? So my domain. For the domain, you can always start with that endpoint, because again, notice we have an endpoint here and an arrow here. So the endpoint starts at +3, and then it's not going to the right this time. Notice my arrow is on the left of 3. So that means it's pointing to the left. So my x values, they're not going to be bigger than 3. The numbers to the left of 3 are getting smaller, so x is less than 3. And it's an open circle, so I keep it less than, not less than or equal to. All right, the last thing we're going to do here, you have to look at your range. So again, we can't look at our endpoint because there is all the y values above where this endpoint is. So we need to look at the vertex. So my vertex is right here, and the y value at that point is 3. So that's where we're going to start. And notice that here, my parabola is opening down. So that means I'm going to draw my arrow down the y-axis. It's pointing down. So the y values, since they're going down from 3, that means they're getting smaller. They have to be less than that 3, and it's a closed circle, so less than or equal to 3. And that's our range for that graph. All right, so you have some work to do so you can practice these properties of quadratics. If you missed something, I am putting this video in Canvas so that you can go back and look at it and maybe listen to a explanation that maybe you missed or just needed to hear again. All right, so this is up on Canvas for you to view again.